There is a plant growing through the cracks of your driveway right now. It produces more protein per grain than wheat. Planted once, it grows back and produces a full harvest 5 times from the same root system, without replanting, without fertilizer, without irrigation. Civilizations were cultivating it 8,000 years ago, 3,000 years before the Egyptians built the first pyramid. Every empire that relied on it thrived, and then it vanished from Western agriculture almost overnight. In 1975, the National Academy of Sciences analyzed its amino acid profile and found something that violated a fundamental rule of grain biology. Their report called it the most promising unexploited crop in the world. Within 1 generation, it was reclassified, not as a crop but as a weed. In 1964, archaeologists excavating cave sediments in the Tehuacán Valley, Puebla, Mexico, recovered a cache of preserved seeds. Carbon dating placed them at 6000 BCE, 8,000 years old, still intact. The same seeds appear in Aztec imperial tax records. Emperor Montezuma II collected 20,000 tons of this grain annually as tribute, more than he collected of corn, not a side crop, the foundation of an empire's economy. Independently, with zero contact, farmers in the Himalayan foothills of Nepal were growing the same plant. So were communities across sub-Saharan Africa. So were villagers in coastal India. 4 continents, no shared trade route, same crop. The plant has a name, one that most people alive today have never heard spoken. Amaranth. Genius. Amaranthus. From the Greek amaranthos, the one that does not wither. Its seeds contain a compound called squalene, a molecule that, until amaranth was analyzed, had been found almost exclusively in the livers of deep-sea sharks. No one has fully explained why a land plant produces it, and its Greek name, the Undying One, turned out to be far more accurate than the people who named it ever knew. The Aztecs did not simply eat amaranth. They built their most important religious ceremonies around it, mixing the ground grain with honey and human blood to form figures of their gods, then consuming them as sacred communion, an entire spiritual architecture centered on a single plant. In India, amaranth holds a singular distinction. It is the only grain permitted during Navratri, the strictest Hindu religious fasting period, when all other grains are forbidden. Hindus considered it the purest food in existence. In China, they called it the grain of immortality. 3 civilizations, 3 continents, 0 contact. All 3 independently arrived at the same conclusion. This grain was not merely food, it was sacred. What does a plant have to do, biologically, to make 3 unconnected civilizations worship it? In 1975, the National Academy of Sciences published a 187-page report. 18 scientists reviewed 36 tropical plant species to answer one question: which crops could address global protein malnutrition, then affecting 500 million people? One plant scored higher than all 35 others. It was not close. The NAS sends samples to research laboratories across the country. Dr. David Lehman at the Rodale Research Center in Emmaus, Pennsylvania, ran amino acid profiles on amaranth grain. He expected what every grain analysis in history had shown: protein between 8 and 14%, deficient in at least one essential amino acid. Amaranth tested at 14 to 16% protein. Respectable. But the shock was not the quantity. It was one amino acid, lysine. Every major grain on Earth, wheat, rice, corn, barley, oats, sorghum, millet, rye, is deficient in lysine. This is not a trend. It is a fundamental biological constraint. Wheat is deficient. Rice is deficient. Corn is so deficient that populations dependent on it develop pellagra, a disease of protein starvation. Amaranth's lysine content measured at roughly 5% of total protein, nearly double the level in wheat, comparable to cow's milk. For several years, the scientific consensus held amaranth was a better grain. Higher protein, better amino acid balance. Worth studying, not paradigm shifting, just a nutritional upgrade. Then in the early 1980s, independent teams at Purdue University and the University of Sao Paulo ran digestibility studies. Wheat protein digestibility averaged 65 to 70%. 1/3 of its protein passes through the body unused. Amaranth measured at 90%. These findings shattered every existing nutritional model. A single grain consumed alone, no legumes, no animal protein, no supplementation, could provide complete, highly digestible protein equivalent to animal sources. No other grain on Earth can do this. NASA began testing whether amaranth could sustain astronauts on multi-year space missions. The ancient civilizations had not worshipped amaranth out of superstition. Through 8,000 years of observation, they identified the only grain capable of sustaining human life as a sole protein source. Science took until 1983 to confirm what the Aztecs knew by 4000 BCE. Amaranth grain contains 3 times the calcium of wheat, twice the iron, 5 times the potassium, phosphorus, magnesium and zinc at levels that exceed every major cereal grain. In plant biology, there is a well-established resource allocation trade-off. Plants that produce high-protein seeds grow low-quality, often inedible leaves. Plants that produce nutritious edible leaves grow poor seeds. A plant cannot invest heavily in both. Amaranth breaks the trade-off. It produces high-protein grain and highly nutritious edible leaves from the same plant. The leaves contain 4 grams of protein per 100 grams raw, along with vitamins A, C, B6, folate, and manganese. Most grain crops have leaves you cannot eat. Amaranth gives you grain and greens from one root. When these combined results were first presented, researchers at multiple institutions assumed measurement error, contamination, mislabeled samples. Independent teams at Purdue University and the University of Nebraska repeated every analysis from scratch. The results held every time. Amaranth oil contains squalene at concentrations of 6 to 8%, 8 times higher than olive oil. The plant uses C4 photosynthesis, the same water-efficient carbon fixation pathway used by corn, but requires no irrigation infrastructure. From seed to leaf harvest, 45 days. From seed to grain harvest, 90 to 120 days. A single plant produces between 100,000 and 200,000 seeds. Grain yield per acre up to 2,000 pounds, comparable to wheat. Higher protein, complete amino acids, 90% digestible. Edible leaves, drought-resistant, pest-resistant, pest-resistant. Faster to maturity. Equal yield per acre. One plant. In rural Mexico, Guatemala, and southern India, amaranth consumption persisted despite centuries of suppression. Researchers studying these communities documented significantly lower rates of childhood protein energy malnutrition compared to neighboring populations dependent on corn or wheat alone. The grain was doing exactly what 8,000 years of cultivation suggested it would. In 2012, the Food and Agriculture Organization of the United Nations formally classified amaranth as a critical food resource for combating childhood malnutrition in developing nations. That same year, in the United States, the most common species of amaranth, Amaranthus palmeri, remained officially classified by the USDA as a noxious weed. Farmers received federal subsidies to destroy it. The most nutritious grain on Earth, classified as something to poison. So if one plant outperforms wheat in protein, grows without irrigation, and regrows 5 times from one root, why is no one growing it? Why is the most complete protein in the plant kingdom growing in your yard labeled a weed? Every major grain on Earth, wheat, rice, corn, barley, oats, produces incomplete protein. Each is deficient in at least one essential amino acid. This is why every traditional food culture invented protein complementation. Rice and beans, wheat and lentils, corn and black beans, tortilla and friolos. Every pairing exists because no single grain was ever enough. Quinoa and buckwheat improved the model. They contain all 9 essential amino acids, but digestibility hovers around 75 to 80%. The body cannot access all the protein they contain. Soy took a different approach. High protein, 36%, complete amino acids, but soy demands fertile soil, significant water, and heavy inputs. It grows overwhelmingly as GMO monoculture. It contains anti-nutrient compounds that reduce mineral absorption. Amaranth combines the amino acid completeness of quinoa with 90% digestibility, the highest ever recorded. It grows in poor soil. needs almost no water, resists pests without pesticides, produces grain and edible leaves from the same plant. In tropical climates, it regrows from the same root, yielding 5 harvests per year. It does not outperform other grains in one category. It operates on different biological rules. Imagine every grain as a vehicle that needs fuel and the mechanic. Wheat breaks down without irrigation. Rice stalls without flooded fields. Corn needs a factory to stay fed. Amaranth runs on sunlight and rebuilds from its own root system. But even that analogy undersells it. No engine grows back after you dismantle it. Amaranth does. Dr. Ricardo Bressani, a Guatemalan biochemist who spent 3 decades at the Institute of Nutrition of Central America and Panama, analyzed over 80 plant species for human nutritional potential. His conclusion, amaranth's amino acid composition, was the closest thing in the plant kingdom to an ideal protein for human nutrition. The rule the National Academy of Sciences found violated: cereal grains cannot produce complete, highly digestible protein. That rule held for every grain ever tested. Amaranth broke it, not marginally, not as an outlier, but categorically. NASA included amaranth in their controlled ecological life support system. Crops selected to feed human crews beyond Earth orbit, a grain outlawed by conquistadors 500 years ago, chosen to feed astronauts on Mars. Amaranth flour reduces LDL cholesterol in animal models by up to 50%. Its oil contains tocotrienols, a rare form of vitamin E most crops cannot produce. The squalene in amaranth seeds, the deep-sea shark molecule, functions as an oxygen carrier in cellular membranes, enabling photosynthesis in extreme heat. The Russian Academy of Sciences confirmed amaranth produces more squalene per cultivated acre than any other land plant. The cosmetics industry kills 3 million sharks annually for squalene. Amaranth could replace every drop from a field, not an ocean. A single plant produces up to 200,000 seeds. Those seeds remain viable in soil for decades. Waiting. One agronomist at the University of Nebraska described attempting to eradicate amaranth from a test plot as the most humbling experience of my professional career. Amaranth survives herbicides. It survives drought. It survives poor soil, extreme heat, and neglect. It survived 500 years of deliberate eradication campaigns. In 1519, Hernán Cortés landed on the coast of Veracruz. Within 2 years, he dismantled the Aztec Empire. But military conquest was not sufficient. The Aztecs' spiritual identity was bound to their food. During Panquetzalistli, priests mixed ground amaranth with honey and sacrificial blood to form tzoale, dough shaped into effigies of Huitzilopochtli, distributed as sacred communion. Spanish missionaries called it a demonic parody of the Eucharist. Cortés issued a decree: any person found growing or selling amaranth would have their hands cut off, fields burned, seed stores destroyed. An 8,000-year-old crop criminalized overnight. The colonial ban ended centuries ago. Amaranth never recovered, not because it stopped growing, but because modern agriculture made its erasure profitable. Wheat generates $350 billion annually. Corn generates $200 billion. Bayer, Syngenta, and Corteva built empires on patented seeds and proprietary chemicals. The USDA distributes billions in subsidies to wheat and corn farmers. None apply to amaranth. You cannot patent it. Amaranth breeds true from saved seed. You cannot sell fertilizer. It grows without inputs. You cannot sell herbicide to protect it. Amaranth is the weed those herbicides kill. Wheat needs irrigation. Corn needs fertilizer. Rice needs flooding. Soy needs corporate contracts. Every dominant grain depends on industrial infrastructure. Amaranth needs nothing. The grain NASA selected, the United Nations endorsed, classified in the United States as a noxious weed. Not because of what it is, because of what it threatens. The world's most complete food. Labeled the world's most persistent pest. But not everywhere. The reversal has already begun, and it did not start in a university. In Mexico, they call it alegria, joy, and pop the seeds into candy bars sold on every street corner. In India, it is rajara, the king's grain, the only food permitted during the strictest Hindu fasting. In Nepal, Farmers grow it at 10,000 feet of elevation where no other grain survives. In Nigeria, the leaves are called efotete and cooked as a daily staple grain. In Peru, kiwicha grain is stirred into breakfast porridge for children. In Greece, the country that named it, amaranth still grows wild on limestone hillsides, unharvested, unrecognized. Half the world never stopped eating it. The other half was taught to spray it with Roundup. Global temperatures rising, aquifers draining, topsoil eroding, fertilizer prices have doubled in a decade. Every trend is a death sentence for wheat, corn and rice. Every condition is where amaranth thrives, hotter, drier, poorer soil. The future looks exactly like the environment amaranth was built for. The reversal is led by farmers in Mexico, India and East Africa reintroducing amaranth from saved seed. But there is one thing any person, including you, can do that matters more than eating it. The solution is not being engineered. It is growing through the cracks of your sidewalk. The first step is recognition. Amaranth grows wild across every continent except Antarctica. You have walked past it. Look for tall plants, 3 to 8 feet, with thick reddish or purple stems. Leaves are diamond-shaped with prominent veins. Seed heads are dense, bristly, and elongated. Green, red, gold, or purple. They look like textured fingers pointing upward. That tall, red-stemmed plant in vacant lots, roadsides, or concrete cracks, that was amaranth. Stop pulling it. Stop spraying it. The leaves are edible raw or cooked. Pick young leaves for salads. Cook mature leaves like chard or collards. Sautéed, added to soups, blanched and frozen. For grain, wait until seed heads dry and turn brown. Cut them, rub over a bucket. Blow gently to winnow chaff. Seeds cook in 20 minutes at 1 part seed to 3 parts water. You can pop them like popcorn in a dry skillet. How Mexican alegría is made. Save seeds from the tallest plants. Store them dry in a sealed container. Give them to neighbors, community gardens, schools. Every person you teach to identify, harvest, and save amaranth is one more person who never needs to purchase protein from an industry profiting from an industry profiting from ignorance. That is not gardening. That is food sovereignty. And it is the one thing no industry, empire, or herbicide has stopped. The grain industry does not want you knowing a single plant replaces wheat as complete protein. It makes their $350 billion market unnecessary. The agrochemical industry does not want you knowing the weed they sell herbicide to kill is more nutritious than the crop they sell seed to grow. 500 years ago, an empire did not want you knowing the civilization it destroyed solved protein 8,000 years before science confirmed it. The plant is amaranth. Amaranthus, the one that does not wither, still there, growing through your driveway cracks, waiting. Subscribe if this knowledge should not disappear again. Share this with someone spraying what they should eat. If you think amaranth is the only erased food, the next video shows how deep it goes.